Okay, in this video I'm going to talk about show you how to solve several types of equations. First thing I want to talk about is a radical equation. Now, I'm not going to show you the real nasty radical equations where you have to raise them to powers twice. I'm just going to show you the ones where you just have to do it once. But generally what you want to do is you want to isolate your radical. So here I have a cube root. Now I need that for this to work out seamlessly, I need this cube root to be by itself. So all I have to do to make that happen is just subtract 2 from both sides. So just take 2 away from both sides, and then of course these will cancel, and 0 minus 2 will give you negative 2. So now you can see that I have that radical isolated by itself. Okay, so let's get that out of the way. Alright, now look at the index of the radical. This is a cube root. If you want to eliminate a square root, you square it, right? If you want to eliminate a cube root, you have to cube it. If you want to eliminate a fourth root, you raise it to the fourth power, fifth root to the fifth power, and so on. Now, but you have to do that to both sides. So because it's an equation. So to eliminate this cube root, I need to cube that radical. But I can't just cube the left side, I've got to cube both sides. If I cube one side, I got to cube the other side. So now if I cube this side, it just eliminates the radical, and so I have 3x minus 8. Now when you cube negative 2, that's actually going to be negative 2 times negative 2 times negative 2, and that's going to give you negative 8. But now we have a simple linear equation we can solve, and I think you know how to do this. Add 1 to both sides, and you get 3x equals negative 7, and then divide both sides by 3, and you get negative 7/3. Now, your radical equation might be written as a rational exponent. Well, if you take a look here, I've got 5x plus 3 to the 3/4 power. Okay, so what do I need to do? I want to get rid of this 3/4 power. Well, it turns out if you have something raised to the 3/4 power, if you raise that expression to the reciprocal power, which is 4/3, then that will eliminate the 3/4. Now why? Well, because when you raise something to a power and then raise it to another power, you multiply the two powers, and what happens if you multiply 3/4 times 4/3? Well, then you would just get 5x plus 3. 3/4 times 4/3 is just 1, so you just get 5x plus 3 to the first power, which is just 5x plus 3. So that's why we want to raise it to the 4/3. Now again, you can't raise one side to the 4/3 unless you raise the other side to the 4/3. So I'm going to raise negative 8 to the 4/3. Now, I've shown you in an earlier video, when you do this, this is the same as saying the cube root, this denominator is the root. So this would be the cube root of negative 8, which would be negative 2. And then the numerator of that exponent 4 is the power. So that's the same as negative 2 to the 4th power, and I just wrote that there. So I have 5x plus 3 equal negative 2 to the 4th power. Well, negative 2 to the 4th power is 16, and now I have 5x plus 3 equals 16, and so now subtract 3 from both sides, you get 5x is 13, and divide by 5, and you get x equals 13/5. And so that's your answer for that one. Anytime you have an equation where one term is just the square, or one of the variable terms is the square of the other variable term, then you can probably solve it with what's called a U substitution. See, if you'll notice here, this variable here is x to the 1/3, and this variable is x to the 2/3. Well, x to the 2/3 is simply x to the 1/3 squared. So really, this variable is just this variable squared. And so all you have to do, if you were to just do a substitution, and generally we use the letter u. So let's change this to u. Let's say u is x to the 1/3. Okay, well if u is x to the 1/3, then what would x to the 2/3 be? Well, it would just be u squared. So x to the 2/3 is u squared. X to the 1/3 is u, so that would be just minus 2u, and then minus 8. Well, then you can factor this. You know how to factor this. This will factor into u minus 4 and u plus 2. And so if you solve that, you'll get u equal 4 or negative 2. Now here's where most students make the mistake. They stop here. Well, the original problem wants you to solve for x, not u. So what you have to do is this. If u equal 1/4, then what does x equal? That's what we have to figure out. Well, if u is 1/4, remember, u is x to the 1/3, right? So if u is 1/4, let's replace u with x. I mean, not x, but x to the 1/3. So u equal 4, then x to the 1/3 must equal 4. And now we know how to solve this. We can eliminate the 1/3 power by just cubing both sides. So if I cube both sides, I'll get x equal 64. Now a lot of students get this backwards. They think if x to the 1/3 equals 4, then x would equal the cube root of 4. But no, it's actually x would equal 4 cubed. Alright, now the other solution was u equals negative 2. Well, if u is negative 2, then x to the 1/3 would equal negative 2. And then if you cube both sides there, you get x equal negative 8. Now, let me show you, there's a couple of other examples where this, I just want to show you a couple of examples of equations that fall in this form. I'm not going to solve them, but just so you'll see some equations that could be solved using this method. So focus down here on this. Here I have x to the 10th minus 4x to the 5th plus 4 equals 0. Well, since x to the 10th is just x to the 5th squared, you could make this same type of substitution. Let u equal x to the 5th, and then u squared would equal x to the 10th. So that would become u squared minus 4u minus 4. And then you would solve for u, but then when you're done, you have to remember that u is x to the 5th, then you'd have to solve for x. Here's another example. Suppose we had x to the 1/2 minus 4x to the 1/4 plus 4 equals 0. Well, this one might not be quite as easy to see, but let me show you here. If you let u equal x to the 1/4, then wouldn't u squared be x to the 1/4 squared? Well, what happens if you square x to the 1/4? Don't you get x to the 1/4 times 2? And 1/4 times 2, isn't that x to the 1/2? So u is x to the 1/4, u squared is x to the 1/2. So that can be written as u squared minus 4u minus 4, where u is x to the 1/4 power. So just a couple of other examples there where you can use this method, this u substitution method, to solve. Okay, now I'm going to show you how to solve an absolute value equation. Now, just like with radical equations, when you solve an absolute value equation, you want to try to isolate the absolute value. So notice here I have the absolute value of 14x minus 8 with the minus 6 on the outside equals 0. Well, what I want to do is I want to add 6 to both sides so I can get the absolute value by itself. And so now I have the absolute value of 14x minus 8 equals 6. Well, there's a property that actually says that if you have the absolute value of e, I'm going to say e for expression, is equal to a constant, where k is a constant, then that has two solutions. Either e equals minus the constant, or e equals plus the constant. Okay? Now, this assumes k is not a negative number, because if k was a negative number, then it wouldn't make any sense anyway, because the absolute value of an expression can't be negative. So, if I have the absolute value of this expression, 14x minus 8, equal to 6, to eliminate the absolute value, I have to solve two equations. I have to take the expression out and set it equal to negative the number, and that's what I did here. 14x minus 8 equal negative 6, and then take the expression out and set it equal to positive number. Now remember, when you use this property, you lose the absolute value symbols. So notice I don't have the absolute value symbols here. So I just have 14x minus 8 equal negative 6. Now if you add 8 to both sides, 8 minus 6 is 2, so you get 14x equals 2. So x is 2/14 or 1/7. Now, you also have to solve 14x minus 8 equal 6 plus 6. So here if you add 8 to both sides, you get 14x equals 14, and then if you divide by 14, you get x equals 1. So the two answers that satisfy that equation are x equal 1/7 and x equal 1. And that's pretty much all I have to say about solving equations at this point. There are some other types of equations that you might run into later, depending on what courses you take. Exponential equations, log equations, trigonometric equations, and so forth. But that's all I'm going to talk about at this point. My next video is going to move on and talk about solving inequalities, which are similar to equations, but they're different.